Hello, I'm Sean from Becker Orthopedic. Today I'm going to discuss with you the Miline metric interchangeable components introduced at Becker Orthopedic. Hopefully this presentation gives you a better indication of how you may use these in your clinical practice and a deeper understanding of how the joints will function. Becker has a rich history of manufacturing, and we are celebrating over 92 years of excellence this year in 2025. It began as a clinical practice in 1933 with Otto Becker and Lucille Becker, who moved the business up to Michigan to utilize the manufacturing experience of the automotive industry that was emerging in the 1940s, and began officially Becker Orthopedic Appliance Company. When Otto Becker unfortunately passed away, his wife Lucille, who was the first certified female orthotist in the country, took over the reins and began to expand some of the product line, including the first double-action ankle joint, which was patented in 1963. This was the first time you could put resistance, springs, or pins on either side of the ankle axis. Later, the double-action ankle joint was further updated in 2007 with the slimline component, which had a smaller body but still used some of the traditional spring strengths. Things have changed in a big way here at Becker since the triple action joint has been developed. This was released in 2015 and 16. The triple action A, B, and C sizes. Those can be found on separate presentations. But from the knowledge of how we've manufactured the triple action hinge, we have further expanded that into updating our legacy products into these higher functioning durable products that are the Miline family. Today we'll review all these components and how they can be used in your orthotic use. We do believe that this allows for you to broaden your design options with a wide range of the sizes, the functional types, bar geometries suitable for single or double upright AFO, KFO designs. Single use in composite materials, double upright is required in thermoplastics. You can add free motion companion or other joints as a companion joint to help with the torsional stiffness as required. Again, we'll review that as this presentation continues. The interchangeability allows us to use the same bars and same stirrups to change the functional use of these components. And having stronger spring strengths allows us increased resistance options for improving our management strategies with our patients. We'll discuss now some of the core features that these components offers. This area above the channel we call a booster, and it allows us to use even higher strength springs that have a greater mechanical advantage because of the distance they are from the pivot. This vertical position above the pivot allows for the spring to effectively have a greater level of resistance as it is compressed. And by preloading, adds to the resistance to help manage the forces of the patient's weight and ground reaction. In a channel that doesn't have a booster, the screw comes with it, a rubber ring that adds anti-migration to the screw position and means you don't have to use Loctite on that screw. The springs have been custom designed and manufactured with partnerships that we have found to our specification, and the high stiffness, durable springs will last your patient much longer in these components than our traditional designs. The uprights are designed to be a very tight fit in the component and may require slight machining even to fully fit, but we want a tight fit of the upper bar into the joint pocket. And you can further add some additional resin into the bar pocket if necessary to help keep from any migration or movement, but you want a tight fit of the upper bar to the joint component. We also are using even higher strength steel and metals in our bushings, and we're using torque screws, which give you higher resistance to wear and durability for the componentry. We're giving you precise reading or alignment of the angles as you make adjustments. This allows you to know how the brace was adjusted while you're making changes and the patient is wearing the orthosis. But also as the patient returns to you, you can record if there's been any changes to the alignment or the position of the device. The interchangeable stirrup allows you to go between the different Miline functional components and change out how that orthosis may be working or functioning for the individual as well too, which is definitely unique. On the boosters, different from our triple action, which was a screw on the back of the joint body, we're using a small clamp that is at the base of the booster. This helps prevent the booster from migrating, and since you can't remove a booster from a channel, it acts as your thread locker when you're done adjusting the component. We are using a higher strength steel that is corrosion resistant and durable for your patient's use. Inside of the joint clevis, between the joint body and the stirrup, are wear plate washers or thrust washers. These get greased and help prevent wear of metal parts rubbing on each other, and also help reduce noise because of the grease that you apply to them. We'll talk about those components a little bit more. You want to have a tight fit in the joint clevis, so we give you some different options so that you can make sure that you fit the component snugly when you manufacture it. There are higher weight limits as well on these components, and the weight chart was on the bottom of that last slide, but you can further find it on our website. When we install those thrust washers, there comes this little tool, and you gain the ability to make that tight fit within the pocket to install those. We'll have a further video on that in a moment. The double action joints, there are actually going to be 3 options without boosters, and then each joint, you have to think about which channel the booster is in for the part number information. This is important because if you want a booster in a posterior channel, that booster on the left medial side of the ankle, that joint would be a right lateral ankle, and vice versa. So if the booster wanted to be in the anterior channel, you need a different part number for those reasons. Long range of motion springs and motion limiters are included in the springs, so a pin that fits inside the spring is included when you're ordering a non-booster model. Booster spring options for extended applications, but important to note, boosters are unable to be removed. So if you need a model that has a booster and you've got one that doesn't, you have to order a new joint and replace that on your patient. But you don't have to fabricate a new orthosis to change that resistance level. We do have a systematic process we use for tuning in our triple action, and we're now bringing that procedure also into double action so that we have a set way of having repeatable results in the outcomes we're having for each patient. Double action springs can be preloaded by opposition of a pin, which gives you an opportunity to help control those ground reaction and moments of the gait cycle. I'll review that a little bit more shortly. Action springs and pin packs are different, of course, if you're ordering a non-booster model versus a booster model. So in non-booster models, it depends on the size of joint. With the 20 millimeter, you'll get the same rate spring with the motion limiter pin and a ball to go in each channel. And in a 16 millimeter, you'll get 2 different size springs, one heavier resistance versus a lighter resistance spring, each with the appropriate motion limiter pin that would fit inside of them. The limiter pin does a couple things. Besides the patient having a limitation in the movement of the direction that the spring is in, it also will help you as a clinician. If you bottom that out, you're not overloading that spring that it will fatigue or fail on you. So when you do bottom it out, it takes away all the motion. But of course, you're using a spring, so you back it up and allow the amount of freedom that is needed. If you do want to bottom it out, then you should replace that with a pin, which these springs also come with a pin pack for that reason. The non-booster models come with a pin pack for that reason. The Miline booster spring packs are going to come differently. Again, in the 20 and 16 millimeter options, they come with this long hat pin, which goes down into the booster channel, and we apply a little 3-in-1 oil to that pin as we install it. And then we grease with the Teflon grease that comes with these joints as well. We put a little of the Teflon grease on all the springs. And this pin acts as your motion limiter pin and will communicate with the pin that is in your lower channel, which we call the coupler pin. There's also a stop pin which will fit in your opposite channel. So to load these springs, they need to be compressed both from the bottom and from the top, and that helps to load the springs. In each channel of the 16 and 20 millimeter, we fit a washer right above the springs, and then there's a plate that's in the booster that connects to the top of the booster cap. And that plate helps to resist from the top of the springs while you're also loading from the bottom of the spring as well, too. The non-booster channel will have that adjustment screw with the O-ring, as I mentioned, and that helps to prevent the screw from moving or migrating during use. So just to review, and all these shorter videos for assembly are on our website. On the 16 and 20 millimeter, you're going to have different spring condition options. B3 will be your most resistive option, and to place these springs in the channel, we're going to loosen the booster up, remove the cap screw, the keeper plate comes out, we're going to grease that pin, and then oil the pin and then grease our springs. We add the cup washer on the top, the keeper plate goes back on top, and then the cap will return on top of the booster. In cases where you're only using the skinnier spring, it comes with that additional plastic sleeve to fit around the spring so the spring is stable within the booster for lesser resistance options. The 13 millimeter you have to make a decision on what you are putting inside of the booster. So you have an option of the shorter range of motion high stiffness spring, or you can use the longer range of motion less resistive spring. So it depends on what your patient needs. Even though these are the same springs that come when you order a non-booster model, by putting them in the booster, it does a couple things. It increases the spring resistance because of the distance it is from the pivot. It has an improved mechanical advantage, but it also keeps the spring looking very healthy because no sand or dirt or lint from socks are going to reach the springs, and they'll remain nice and greased and functioning very well for you as a component. So. I mentioned before that we're going to use a similar systematic tuning procedure with our new double action ankle joints that we are accustomed to with triple action. We begin by doing a bench alignment whenever we make these. So we will set the range of motion on the stirrup to 0 by fully compressing the booster spring and aligning. Now there's an interdependence of adjustment on any double action joint. So one channel, when you adjust one side, has an effect on the other side. So our goal for bench alignment is to set it at our fabrication angle, which would be 0 relative to the cast correction. But it would be 0 on your alignment of your joint body on the stirrup. Then we try it on the patient, and we begin with postural standing alignment in static positioning, and I'm looking for an improved shank to vertical angle of 7 to 10 degrees, finding good balance for your patient, and making sure their femur is nice and vertical in static alignment. Then we're going to progress towards more dynamic alignment, but before we do that, we watch that patient walk with the joint not moving yet dynamically. So that step 3 is swing phase alignment. They step. We want to make sure that they have appropriate foot to floor clearance through swing phase. They're not catching their toe, and they're not having an issue with knee instability into hyperextension or early flexion. Now, because we're locked, we do expect fact, maybe the kinematic movement is still over accelerated. But just focusing at initial contact, where is that knee position? And if we have done step 2 really well, then usually in step 3, you may only have very slight minor adjustments. For example, a patient with really weak hip flexors, maybe they need another half a degree or a degree of dorsiflexion just to assure they clear that foot through swing phase. But again, typically step 2 done well in static standing. By step 3, there's minimal adjustments for alignment changes. It's just a confirmation that the alignment is appropriate to begin now dynamic adjustments. Step 4, now our goal as orthotists is to be the least restrictive orthotic as possible. So we're going to start backing up the compression on that posterior booster spring. And we want to back it up until we have an appropriate heel contact to foot contact. Now our habit here is to begin with the higher resistance level of springs and then work towards maybe less resistance as the patient can tolerate it. So if we're beginning with a high resistance spring, what I want to see is a good heel contact to foot to floor contact without accelerating the knee into early flexion. If we get adjusted with more than 10 degrees of motion, then we may consider going inside that booster and seeing if a lesser resistance spring is appropriate for early stance phase adjustments. Your final stance phase adjustability is less because now we have an anterior pin. If you want to have a full adjustability in all phases of stance phase of gait, then you need to use a triple action component. But for some patients who have poor knee instability, they're crouch gait walkers, any tibial progression forward might cause their knee to buckle or cause them to crouch, and they're just going to push past any resistance of spring and stance phase of gait, then the double action component is appropriate for this. And the heel will rise off the ground as they hit that anterior stop. But you can't dynamically adjust it. It will be much closer to that static alignment that heel starts to rise off the ground. So this is your opportunity for adjusting when there's a posterior booster. Now we look at the options for if that booster is in the anterior channel. Again, we start with bench alignment. Fully screw it down, no motion. Static alignment, if we have to adjust one side, you have to adjust the other to remain static. Swing phase of alignment, just assuring that we have good heel contact at initial contact, that we have an appropriate foot to floor angle, that we're not catching our toe through mid-swing or terminal swing, and that the knee is in an appropriate position for initial contact. We're not going to be able to adjust early stance phase of gait alignment, so this may be helpful on a patient with significant knee hyperextension issues or where we don't want to allow for any plantar flexion because of concern of further contracture or loss of contracture issue. And then what we can adjust for, though, is how that foot then progresses forward and the more dynamics of push-off. So from mid-stance, how long is that step? Is the femur progressing into further extension? And are you getting that late knee extension as the heel rises off the ground? Again, if you want to be able to adjust in both first rocker to second rocker of gait and second to third rocker, then you'd want to look at our triple action component. But for some patients with knee hyperextension issues, further contracture control issues at the ankle, then the double action joint with posterior blocking pin and anterior spring resistance is appropriate. Our dorsiflexion assist hinges also come with options of boosters or non-booster models. So the non-booster models, so there's actually 12 different joints here, the mirror images of these as well too. And again, you have to consider what side of the ankle you're placing the component to have the appropriate part number. These joints can hold the spring resistance through swing phase to the aligned position and then have about 20 degrees of travel towards resistance. So in this case, The aligned position of swing phase of gait will hold the AFO at the angle through swing phase, and the strength of springs resist that ability of the patient to plantar flex through swing phase. And as they have initial contact on the ground, then there'll be upward to a 20-degree position of plantar flexion. That would be the max allowance of travel you'd want to have from the contact point to foot flat. Typically, our patients will need a little bit more control of that, though. But what you're really allowing for is swing phase assistance and some resistance towards that initial contact to foot flat of the gait. Again, higher level of resistance with our booster models because of their mechanical advantage and the size and strength springs you can use in the 16 or 20 millimeter versions. Our standard action joint can fit onto the Miline interchangeable stirrups and provide free motion. There is also a specific standard action stirrup, which can be used for more traditional range of motion control adjustability, which I'll talk more about when we look at those hinges. So the standard action joint can also be used as a companion hinge, and as a companion hinge then can be swapped out to a different component. So let's for a moment look at the stirrup options. In the Miline components, we have a rivet stirrup, a Y stirrup, which is interchangeable. This would be the most common stirrup we use, and the standard action stirrup. So the interchangeable stirrups allow us to put the different joint bodies and change the function of use. Again, they're high strength, fatigue, and corrosion resistant stainless steel. The heavy duty option, there is an available heavy duty option in our 16 millimeter. And the 20 millimeter isn't labeled as heavy duty, but this is obviously our larger component. It's going to be manufactured in a heavy duty format only. We can have some extendable service life with these components as they're easily swapped and changed in thermoplastics or other design types. The standard action joint is a little different than our traditional standard action stirrup. So traditionally it would have just been at that horizontal line. And if you grind at that horizontal line, then there is 0 degrees of motion in the plantar flexion or dorsiflexion. If a patient were contracted and the device is being fabricated at a 0 degree position, it allows you to grind on a 3 degree angle or 4 degree angle and set the brace at 4 degrees of plantar flexion or 3 degrees of plantar flexion following our laser etchings. You can also grind in an arc of range of motion. So you can grind on the 3 degree line for plantar flexion and 5 degree line for dorsiflexion, and then there'll be an arc of motion. Of course, the disadvantage of this is you're stuck with any removal that you have made, and if you need more restriction, you have to then refabricate your orthosis with a different stirrup. The rivet stirrups are compatible with our split caliper plates for double upright use only. So if you're using a rivet stirrup, it should be placed in a double upright option. The 16 millimeter and 20 millimeters will fit into the A and B sizes and have a long tongue stirrup availability. Our C size will only fit in the short tongue models. So those are our 3400 or 3400-X. A and B is available in the X and correlate with the 20 and 16 millimeters. Upright options with Miline. So you have to also consider what upright you're ordering with the component. So you order your component, your stirrup, and your upright. There are short bar uprights which are used in standard fabrication for double upright options. There is a HD unilateral upright indicated for composite versions of the fabrication and recommended for monolateral use. So if you're using a component just on one side, we recommend you using our HD upright, and they're shorter bars. So this allows a disconnection between the ankle component and the knee joint too in a KFO fabrication. There's a number of advantages to doing this. It decouples some of the stress between the ankle joint and the knee joint. Say a patient falls or twists or break something, it will have less of a consequence and make the whole device a lot more serviceable. The ability to switch that fabricated KFO, for example, down to an AFO is rather quick, and you can make that change over or change it for the patient as they progress or change through their condition rather easily. It also helps improve the manufacturing time and the quality of manufacturing that an individual can do with the componentry. We do offer a long bar option, which is intended for conventional use and always in bilateral use of the upright. Here's a slide that helps to demonstrate just that interchangeability of the component. So initial fabrication included a booster, and that was found to be too resistive, or you decided you didn't want to stop in the anterior, you just wanted a dorsiflexion assist. You can swap that component out, and now we have free motion at the ankle too. So you can swap the component out, and you've changed how that orthosis functions with these different joint bodies, and giving your patient some more options in what can be done. If you are fabricating an orthosis in thermoplastics, it does require a double upright. You can also use, of course, double uprights in composites if you need more coronal or transverse control. With our triple action component, we did manufacture this camber axis companion joint. It is similar in shape to our traditional camber axis joint. However, it doesn't have any of the lock keys. It's made from a stronger strength steel, and it uses a torque screw through the middle of it. So that part number is 751 ATA and can be bent to the model as you fabricate. The 13 millimeter joint, you can use a medium-sized tamarack joint, and the flexor joint can be used on the opposite side. We recommend thermoforming directly over the flexor and not over a dummy in this case. And you may sacrifice, if you're buying the pair, the one when you're cutting it off, or be careful how you're cutting it off so you don't ruin the part. But that helps with the joint spacing because the dummies are actually slightly different when you're using bilaterals, because when you cut away, it helps prevent too much loss of material. With the Miline component, if you're using a double action, say on one side of the ankle, and you're using a free action standard action on the other side, this allows you some flexibility too with your design. So when you're fitting and delivering that orthosis to the patient, if you find you don't have enough resistance, now you can switch out the standard action joint and put another double action joint on the other side. And this will help then to give increased resistance levels and change how that orthosis is potentially working. So it is a good idea to consider using a standard action companion joint. It also gives a much greater resistance towards torque than some of these other options will have. So the do's and don'ts there: do match with a free motion companion with sufficient torsional support. So, and that may be a standard action joint. Always match with a paired dynamic component and adjust symmetrically. So if you have a double action joint in each channel with boosters, you need to have that booster on the opposite side too. You can't use a non-booster model with a booster model. And it's always important when adjusting mechanical hinges that are bilateral like that, that you have symmetrical adjustments so there's not torque introduced into the system as well, which is a good reason why we have added those scales on the stirrups, and you can monitor as you turn the boosters that you've turned them equally on both sides. It's also another reason why it's important to zero out the motion in those hinges as you start the adjustment process. So as you adjust it, you're equally making adjustments on each side of the hinge that will help the durability of your product and the safety for the component. You don't want to do this. This was an example where they matched a double action with a booster in the anterior channel and just a double action joint. This, fortunately, was a sample and didn't go on a patient. But want to make sure that you are aware the dynamic components do need to match if you're making that change. It's okay if it's a standard action and is just free motion as a companion hinge, of course. Some other important differences to note from other traditional Becker components: the double action joint will not have balls below the pins. So if you are using just a pin in the channel, you want to not put a ball underneath there. It was designed by the engineers to not include that. And in booster models, because you can't remove the booster from the channel, we had to find a way for you to be able to slide these pins. If you need to use the shorter pin under the booster, say your patient got contracted from the time you evaluated them, or something has changed about their condition, you need to use a shorter pin. You can put that underneath the booster side if necessary. So if you back off that anterior screw so that the rubber ring is visible, and you back off the booster, now you can move the stirrup from side to side enough that you'll be able to insert the pins from the bottom. However, if you my habit here is usually to install the pin underneath the booster spring, move the stirrup over, then drop the pin in from the top, and then apply the screw into the non-booster side of the channel. But because we couldn't make the boosters, we had to be able to make that movement occur so things won't fall out. If you don't have things screwed in enough, they're going to fall out on you. So as long as the screw in that anterior channel, you're no longer visible to the rubber ring, then things will not fall out. Of the base. Thrust washer installation, you do come with different size thrust washer plates. They're indicated by the number of, thickness is indicated by the number of dashes on the plate. So 0 will be the thinnest plate, 1, 2, 3, 4, and 5. Some slight differences on the number of plates you get based on the size of joint you have. But here it comes with this installation tool. The grease, it comes in a white packet. We put that Teflon grease onto the thrust washers, hang them on and we also grease the stirrup as well. And then we hang that onto the installation tool. We bring the joint over the top of the installation tool. You use your bushing to push out the installation tool, and then that way that you don't struggle with the alignment of those. So there's a short video again on our website that you can watch to learn more about the installation of the the thrust washers. But it's important that you have a nice tight fit in your clevis space. So you can see here you get 2 sets of washers included with each joint, indicated by the notches on the thickness, so you don't have to look it up. And you can just try to determine. Now, most of the time, size 1 on both sides of the spring. It does matter if you're using, of course, an HD stirrup or a standard stirrup, which is why we had to give some variability to the thrust washers as well. So we like to test this first with the best fit on the individual. There's very small differences, of course, on the thickness. One pro tip here is put those notches facing down, not facing up, as the video shows. That will help make the installation process even easier. So we tested it with a size 1 and size 2. Didn't quite like the tightness of that, so now we're going to swap it out. So 2 size 2s are being used. Push out that installation tool. Of course, we're going to add blue Loctite. And then on each joint body, there is a Newton meters indicated for the correct torque to put on our screws for that specific component. That would be the same torque on the upper bar screws as it is on the pivot screw. So use your torque wrench, apply your blue Loctite, add the torque to the joint. There's specific torques for that. If you're new to Miline, I highly recommend that you purchase the Miline Fabrication tool. It is something that will fit all the joints, all the sizes, and will help with your fabrication and alignment process. It comes with a alignment rod, so when you drill your ankle axis on your cast, you leave that in the negative model as you fill your model, and then as you remove that, the fabrication tool will fit perfectly into that slot. The tool maintains this collinear alignment. It does that because the alignment tool will overlap, and this will fit, we found, over 95% of all the ankle MLs that we fabricate AFOs for in thermoplastics or composites. The fabrication tool comes with joint spacers, and the tool comes with these different faces, the adapter plates. And the adapter plate you want to use is based on your stirrup, so it's a different adapter plate for the standard action stirrup than it is for the interchangeable stirrup. And it holds the upper bar and the stirrup in a nice vertical alignment and will help to keep the two joints collinear because of how they overlap and meet in the middle. There is a shim when you're just using a unilateral Miline component, say you're using a different companion component or you're doing a composite manufacturing. This allows you to, again, do this manufacturing without having to fabricate over the joint and hopefully avoiding damage to the component during the fabrication process. So this is a short tutorial we have online. Again, our habit is to not build up our malleoli. What we do instead is use our spacers to indicate the distance. So our standard of 3 millimeter or 5 millimeter difference, and there's different plates or washers that we come with. And you'll watch here rotating them together. Now I'll just rotate one side, and now both will collinearly move to one another. Again, if we're just doing a unilateral component, so in this example, we're going to use a tamarack hinge on the other side that we're manufacturing. So we use our spacer. We're going to apply the bushing shim so that the rod of the fabrication tool stays horizontal within our hole. And I have the appropriate distance. We're going to mark the cast, and we do a bisection here above the ankle and in the calf section and draw a vertical alignment. This will correspond to the corrected vertical position or the alignment angle that you decided to correct your cast model to, or you casted your patient in. We're going to use that as a reference point to continue to set up our adjustments as we bend and contour the bars. So as we contour the bar shape, we begin always using a soft jaw vise. Again, we want to avoid putting tool marks onto this. We do not want to bend the bar in the area that fits within the component. So the part that fits onto your fabrication tool, that's your no bend zone. The upper bars for Miline come with a pre-bend in them. And the reason for that is because this is, if you're using a booster model, kind of the minimal amount of clearance that we need for that booster to be away from that. But you may have to increase your offset as well. So that's what we're doing right now. We're going to that area and we're just increasing the size of the bends at that pre-bent area. And we're going to go back and forth and check it on our model and try to get the bend to the right position at first. So this helps to indicate too for technicians exactly the right place to bend at for that offset initially. And of course you can bend up the bar or contour further away as needed. You can put the part, of course, that fits inside your fabrication tool. And typically we increase on the upper bar, we increase our bend and position, and we may do a twist there at the end to help the bar lay nice and flush. When we're satisfied with that, we're going to add a screw, and the fabrication kit comes with the screw, but these are standard screws you can find at your local hardware store as well too, or you may have for other manufacturing purposes. We're going to screw the upper bar and verify, okay, we've got good contact everywhere with our model. We're going to have to do minimal backfill, and that's what we're aiming for. With our stirrup, we may want to trim it first before we begin any bending process. So we're going to bend and chamfer those edges or round the edges at the appropriate distances. The fabrication the stirrup will come with a protective coating over it so that as you're bending, you're not marring in the area where the laser marks are. In this video, he's going to remove that as he screws it down, but our habit actually is to leave that plastic on as long as possible so that those laser marks are covered, and we're actually just poke a hole and screw it directly onto the fabrication tool. So in the case of bending the stirrups, we begin with a twist. So we twist back towards the heel to begin with, and then we're going to add further contours to the bend. So typically we begin with a twist bend, and then we begin by bending back towards, or the offsets back towards the ankle or the anatomy as much as possible, or away if necessary, and then increase further contouring bends of the ears of the Y stirrup as necessary. On this model, obviously not very much was required there. Again, he removed the protective coating. Our habit there is to not do that now. We're going to leave that on for as long as we can, and then when we get to the point of sandblasting our component later on, we're going to also cover that area maybe with further electric tape because we don't want to get rid of our laser etchings. This is a tip and trick we've used with some success for backfilling, so you can use some foam from a foam box impression model and push it down and then cut away. If some of it falls out, you can backfill or push some of it in. We've also found that, like on bigger offsets, you may have to skim coat it still with some plaster if you prefer this compared to all the plaster backfilling process. It's a little quicker on the cleanup process. We do cover now from the top of the fabrication to the bottom of the fabrication with Aliplast before thermoforming, and then that helps when you're cutting off with the cast saw not to mar the stirrup or the upper bar or cutting the fabrication tool off. So that shorter video is available on our Miline page and may be useful for you. We do provide 2 maintenance kits that we recommend to clinicians when you're seeing the patient on follow-up. You want to do some disassembly, check the inner parts of the component. How healthy is that stirrup looking? How do those wear plates work? Re-grease the stirrup, re-grease the wear plates as you need to. So there, you can buy the thrust washer kits with the grease. You can also buy the hardware pack. The hardware pack comes with a new bushing. On an active patient, the bushing will begin to gall or wear out faster than any other part of the joint. That's good in the sense that you can repair and replace this more affordable component to the joint body. And check on that. We recommend on 6-month intervals, maintaining these components, relubricating, add new Loctite, retorque the components, verify the adjustment settings are still appropriate for your patient, and do so on 6-month intervals for your patient use. Thank you very much for your interest in these products and working with Becker Orthopedics. I'd love to hear stories on how you're using these newer components, the successes you're having with patients, or any questions you may have. You can email us to our general inbox at mail@beckerorthopedic.net, or specific fabrication or clinical questions can be directed towards me at smchale@beckerorthopedic.com. Thanks and have a great day.